Hi, this is Anuj Antony, UR 15 CS 170. Today, this is my first video for the data structure lab. In this session, I will explain about the first exercise question. So this is the first question for exercise 1. So aim of the experiment is to find the address calculation size for row measure order and column measure order. So we have to create a m into n matrix and we have to write the function for calculating the address of cell in that matrix which is stored in row measure and column measure order. So let's come back to the program. So in this program, I use the header file as IOStream. IOStream is used for all the cout and cin process, and std is used for the standard namespace, is used for all the cout, cin, and all other logical part which has to be declared later. In this program, I declared a server variable as of int type of I, j, k, m, n, s. M and n is for the number of rows and n is for the number of columns and s is for the number of sets. Then I declared an array of size 10 and 10 where 10 is the number of rows and column will be the 10 will be the number of columns. Then I declared a two pointer variable of address as add and base address as ba. Uh, Before going to the program, I should explain that what is a pointer. Pointer is a variable whose value is the address of another variable. Then next step, I declared an array for the three-dimensional set. Now we will go for the two-dimensional array calculation of row measure and column measure. So in this inside this function, I declared a function called matrix. And this I ask the user to enter the number of rows and it will store it as m. And I ask the user to enter the number of columns and it will store it as n. So I written next step I written as ba is equal to m% address of 00. In this, it is reading the value of address as m% ARR. So every variable is a memory location, and every memory location has its own address defined, which can be accessed using the ampersand operator, which denotes an address in a memory. Then I declared a function called row measure. This formula is a very important formula to calculate the value of row measure and column measure. So the address I given as add is equal to base address plus I into n plus j into the size. Here the actual formula was base address plus I minus lower bound, where the lower bound will always be 0. So there is no need of writing as I minus lower bound. So I minus 0 will be I. So that is why I given as address add is equal to ba plus I into n plus j into I. So this is so I given the command as cout calculated address. Then it will calculate the address of row measure and column measure and it will as an end. Now we will go for the three-dimensional array. In this, I declared a function called matrix1. And this also asks the user to enter the number of rows and it will store it as m. And again, I ask the user to enter the number of columns and it will store it as n. And for the three-dimensional array, we need the number of sets. So I ask the user to enter the number of sets. So it will store it as s. Then for again for the three-dimensional array, same thing which we declared in the which we explained in the two-dimensional array as ba is equal to m% of array of 3 for three-dimensional. So is reading the value of the base address. Okay. Then I created a function called row measure 1 for the three-dimensional array. So inside the row measure 1 function, I given the address, which is the formula, the main formula of three-dimensional array. So the formula is address add is equal to base address plus I into m into n plus j into n plus k into size of the array. And this also I didn't use the like I minus lower bond, means I told before that the lower bond will be 0. So I minus 0 will be I. So the formula of row major is there. Address is equal to base address plus I into m into n plus j into n plus k into 1. So it will calculate the address of the three-dimensional array and it will store it as add. Then we'll go inside the main. Inside the main, I created a function called matrix. So this full function is for the calculation for the row major order. In this function of matrix, I used two for means nested for loop of I and j. In first one I assign as for I is equal to 0, I less than m, I plus plus. And for the next one for j is equal to 0, j less than n, j plus plus. So it will calculate the address of the row major order. So cout ampersand of address ij. The row major I written because it will be helpful for printing the output. Then I will go for the column major order. This also I used nested for loop where first I written as j is equal to 0, j less than n, j plus plus, and then the one I is equal to 0, I less than m, I plus plus. And this one the formula is the address add is equal to base address plus I plus j into m. So it will calculate the calculated address which is stored in the address as add. And this is also for the third three-dimensional for row major order. And this also I used three variables or three for loop, nested for loop. In first one I assigned I is equal to 0, I less than m, I plus plus. Second one I used j is equal to 0, j less than n, j plus plus. And the third one for this was the third three dimension, that is why I'm using third variable which has k is equal to 0, k less than s, k plus plus, where s is the number of set which we declare before. So it will cout assign address. After giving that, it will assign the address and it will give a address of three-dimensional array for row major column. And it is then I written row major one. This is used for the output, helpful for the output. Then same thing. This is for the column major order. This also three nested for loop are there. And first one k is equal to 0, k less than s, k plus plus, and another one is j is equal to 0 as an as 0 and j less than n and j plus plus, and I is equal to 0, I less than m, I plus plus. So for calculating the column major order, address is equal to base address plus I into m into n plus k into m plus j. So it will calculate the column major order for the three-dimensional array as address add. So we can see the output. As the user is asking the number of rows, so I will give the number of rows as 4 and the number of column as 3. So as you can see, for this is for the two-dimensional array. The row major order is that, so the assigned address and the calculated address are same. I create a number of rows as 4 and number of column as 3. So the address of 12 it should come. As you can see, it is coming. And this is for the column major order. So for the three-dimensional, again it's asking enter the number of rows. So I'm giving as 3, and it is asking again the number of columns. So I will give as 3 again. And for the three-dimensional, the number of sets also need. So I'm giving as the number of set as 2. So as you can see, the row major order, assigned address and calculated address are same. It's the address for the row major order, and this one is for column major order. Okay. Thank you for watching this video.